Hello and welcome. In this video we're going to talk about the async await feature in JavaScript. First of all, we'll go through brief history of async programming in JavaScript. We'll see how it evolved over time. We'll quickly take a look at the callbacks, promises, generators, and finally async await. So let's get started. Okay, so I already mentioned this, but this is a history of async programming in JavaScript. So it all started back with callbacks in the past, and then we were able to use promises, which was a major shift from callbacks, and then we were also able to use generators. Now I didn't use generators much, I pretty much skipped over them, so I went straight from promises to async await, but generators are in between those two stages. And finally, right now in the present time, we have access to this honestly amazing feature that is called async await. So what I want to do next is I want to present to you a piece of code, and then I want to show you the same piece of code in, say, callbacks, promises, and async in the wait. For the generators, I honestly wouldn't want to show you that because I personally don't have a lot of experience using generators, so I don't want to show you something that maybe I badly written, so I'm going to skip over the generators. So let me show you that, and here it is. So this is the callback example. Now I really didn't want to create the most complex callback example ever, but trust me that this isn't the worst that you can see. It can get much more uglier than this is right now. So what we have here is a function that is supposed to be an endpoint handler. So for example, let's say you were building some sort of a website, and this handle over here will receive requests from the client. For example, the browser sending requests to the server, and this response object is what you can use to actually write back something to the client, for example to the user browsing your website. So now what we have in this example is we are talking with a database, and let's say we have a table or say a collection of users, and we want to find a particular user that will be sent to us via this request. So we want to call this function user.findById and simply pass this request.userid property, but now this function is async one. We don't know how many milliseconds it is going to actually run for, so we need to do this in async manner, because otherwise we're going to block the code, and given that JavaScript is single-threaded language, that wouldn't really work. So now we call this function, and what we do then is we actually pass it as a second argument a totally different function that will get called once this operation finishes. So we say here okay, you go on database and try to find me this particular user, and when you do that, then and only then you call this function that we passed over here. And pretty much everything starting at this line over here and ending over here is the function that we passed to that function over there. Now what this allows us to do is say after this, say on the next line over here, we can maybe do something like console.log, and whatever we do inside of that console.log, once this entire code gets executed, will be printed out before we see any of this, because this isn't done instantaneously. But anyway, you can see how it looks like. And when you pass a callback function, so this function over here is called a callback function, that's the reason why this pattern of programming is called callbacks after all. And when you provide a callback function, you should always provide error as a first argument. So then we can easily check if there is an error by first doing that. And only if there is no error, then we can move on and do something else. So in this example, if there were any errors, we would simply respond back to the client, pretty much forwarding that error to the client. Now you see that we have this other argument called user, and what's going to happen is this function over here, user.findById, in case there are no errors and in case it is able to find that particular user, it will send that user to this callback function, and it will be stored in this variable called user. So now we have access to this user in this callback function from here to here by referencing this user variable. So now what we want to do is that user variable is going to have a property called tasks ID, and pretty much in the same manner, let's say that we want to get access to those tasks. So we again query the database for those tasks given by that ID, so we do pretty much the same thing. And then again we supply the callback function again with error as a first argument and now tasks as a second argument. And then we again simply check, and if there were any errors we simply want to respond back to the client with those errors, and if that wasn't the case we want to do something with those tasks instead. So what we want to do is, for example, like imagine that tasks had a property called completed that is a boolean type, and we simply want to change that to be to true. So now once we actually modified that row or document in our database, we then want to save those tasks, and saving the tasks is again async operation because it is not done instantaneously. So we again need to provide a callback function to it, and this time we don't want to receive any returned value from it. Instead we just want to make sure that that operation was successful. So then we simply check whether the error was there, and if so we again respond to the client with such error, but otherwise we simply respond back to the clients with the message of tasks completed. Okay, so hopefully like this all makes sense and you're able to understand like the flow, and you're also able to understand like why is there a need for these callback functions. And now let's take a look how all of this, like the exact same code, is handled when it comes to the promises. And this is a promises example, and one thing you can spot straight away is like how much clearer and cleaner this code actually is. So this time what we're doing is, given that user.findById is again the same function and it is again async function, we simply call it and we pass whatever argument we actually want. But then instead of supplying a callback function to this line over here, what we then do is we tack on the .then function, and then there we actually supply, you can think of it like callback function, what will happen once this operation is completed. So you can pretty much read it like this, like user.findById requires that user ID like started this process, and then once it's actually completed, only then do you do whatever the code is over here. So when that's done, we can then get a handle on that user's object, and then we can do something. Now here we are going to start another async function called tasks.findById. So we pretty much just return that, and then what happens is we can just attach on like another then to this piece over here, and then this part over here will only get executed once this async operation inside of here is actually completed. And now in the same manner we can do these lines of codes over here, and then tasks.save is yet another async operation, so we want to return that as well. And then we supply another function that should be executed once this is done, and now we don't need any parameters here, so we just respond back to the client saying tasks completed. Now you might be surprised how we didn't do any error handling so far. So what's going on is, using promises you can actually call .catch at the end, which will catch all the errors for you, and then we simply want to respond back to the client with such errors if that was the case. So as you can see, it's much clearer because one, error handling doesn't need to happen all the time. We can just like have a specialized piece of code that is going to handle errors no matter where they actually happened. And two, as you can see, we don't have that nesting pattern that gets really hard to read, that is called callback hell, and sometimes it is referred to like Christmas tree shape, because as you can see it goes kinda like this and then the opposite. So it is definitely like a much neater way to write async code in JavaScript. Now let's take a look at the same example using the async await, and here it is. As you can see, it's much more clearer than what we've been able to see previously. It almost looks like a sync and blocking code, but fortunately it isn't. So what's going on here is, whenever you want to write a async await function, you need to write this keyword async before the function keyword, and once you do that, you actually have ability to use this await keyword inside of that function that is declared to be an async function. Async await is actually all promises under the hood. So like if you really want to get a deep and detailed understanding of async await feature, it's best if you learn promises first, but I'll do my best to at least explain you what's going on over here. So first thing you can notice is we have this try catch construct, and that is how you're able to handle errors in async await functions. So this catch piece over here is similar to the catch piece we have seen over at the promises example. We do all of our error handling inside of here, and inside of our try block over here, what we do is next we call this user.findById, and again we pass the parameters that we wanted, but now we actually write this await keyword in front of it, which will actually tell this function that this operation over here is a async operation and it's not going to happen instantaneously. So this pretty much awaits this function to be resolved, and then it stores the result of it in the variable that we assign on the left. And now this next line, tasks equals await tasks.findById, will only execute after the user equals await user.findById gets resolved. So you can almost like read it like a sync blocking code. So next we await for the tasks, and then we supply this user.tasksId as an argument, and then we get those tasks, and then we can simply like tasks.completed equals true, like modify the tasks, and we can also save the tasks. And you can see, because all these three operations are async, we need to put this await keyword in front. And then we can simply response.send to the client back a message saying task completed. Now if error happened during any of those three operations, the execution flow will jump straight to this catch block over here, and it will respond back to the client with such error. So I hope that now you can appreciate the abilities that async await feature actually gives us as we do our daily JavaScript async programming. So what I want to do next is, I don't want to stop here, but instead I want to go with you through a bunch of async await examples in which I could show you the sequential flow, the parallel flow. I also want to show you like all the loops and iterations that you can do with async await. I'm going to show you some common gotchas that you might be unaware of at this moment, and all in all I just want to like go through a bunch of examples so that you feel confident in your ability to start using this async await feature today. Okay, so now let's do like a bunch of examples so that you can see all the ins and outs of using async await in your code. So what I've done is I've made like three different folders over here. First we have a sequential, then we have parallel, and then we have loops. So those are three topics that we want to go through, and in each of these topics we have, like for the sequential, we have like a naive approach, then I'm going to demonstrate like an issue that happens with it, and then I'll also propose a solution, and that's the same with the parallel. And then for the loops, I'm just going to like go over like the different types of iterations that you can go with using async await, and explain like what you can do and what you can't do. So let's get started with the sequential project example, and let's go in this naive approach. So we have two files that we care about. We have a main.js and we have a processes.js. So if I open main.js file, you see that we simply get a handle on those two processes that we actually have inside of that processes file. And the whole idea about this small project is that we have two processes that are async and that we want to run them sequentially. So now, like in that example that I've shown you in the slides, we have this function main that gets called over here, and then we attach this async keyword in front of this function keyword, and then we do all sort of things inside of here. So what we do is we await for those two processes, and then what we want to do is we want to store their values in these two variables over here, and then simply when all of this is done, we want to use the console.log to actually print out to the terminal the values that we got from those two processes. And then this console.log is simply for like formatting purposes, and we also call these console.time and console.timeEnd functions, which will tell us how long the function has been running for in milliseconds. And if there are any errors, we simply console.error them again to our terminal over here. So now let's take a look in this process.js file and see what's in there. So over here we just export two functions that are also async ones, and in them we simply like output that process has started. We again use time and timeEnd to show to the terminal how long this particular function has been running for, and likewise for this second one. And then we kind of fake this operation by simply waiting 5000 milliseconds, and for this wait function I'm actually using set timeout, but because set timeout is expecting a callback, we're actually using this Promisify function from the util package in Node.js, which will actually turn this set timeout into a promise based function that we can use inside of our async code. So remember, like the async is pretty much like promises with a different interface that we can interact with. So we can't really use callback functions inside of our async function. All of that needs to be promises. That's the reason behind this. And I didn't tell this before, but I'm using Node for this because it's much easier for me to using all sort of things like this that are already built in. But you can of course learn async await and use it for like everything that you do inside of JavaScript, be it backend, be it frontend, your choice. So hopefully like this is making sense. Like this is really simple, fake, made up example, and when both those processes are finished, we simply return some value. For example, process 01 is going to return this process 01 dash value string, and process 02 is going to return this value instead. So now let's actually run this and see what's happening. So I'm going to use my terminal. Let me just bring it up a bit. And then I'm going to navigate to that directory and to that subdirectory. And then I'm going to execute node and then main.js as an entry point. So as you can see, process 01 started and it is taking some time. And then it says process 01 ended and it took roughly 5000 milliseconds. Then the process 02 started and then the process 02 ended, and that one took 3000 milliseconds. And then we see that process 01 returned back to us this value, and likewise for the second process. And then we can see that the total running time for this entire example is 8000 and so milliseconds. And that makes sense because when you take a look here, this one takes 5000 milliseconds roughly and this 3000, so that totally adds up. So that's all good, and as you can see, it seems like it's working, but you might have noticed that I didn't use try catch blocks inside of these two functions, and that is kinda okay, because if this or this function returns an error, it will simply bubble up to this main function, and then we are able to catch it inside of here. So that's good, but we'll see like what bad can happen in doing so in our next example. And now I'll navigate to our second example and show you the changes. So if I open this file, main.js over here, and I close the other one so I don't get confused, we have the same code in our main.js file over here, and our process.js file is also the same, but we did add this throw new error line in this process 01 function. So the process01 is going to actually throw an error once run, and we'll see how it affects everything over here. So let me quickly navigate to that directory, and let's see what happens when I run it. So I'm going to type node main.js, and as you can see, process01 started, and then we get this error over here that process01 failed. So what happened is this code started going sequentially. It came to this point over here. Then the process01 threw an error, and then the execution flow jumped straight from this line to the catch block over here. And that's the reason why nothing of this executed afterwards. So if you have multiple processes that you want to await sequentially, this wouldn't really work, because as soon as one process were to return an error, the rest of them wouldn't get executed. Now, sometimes this is really good, because maybe if this process failed, you just want to exit everything, and then you can use this approach. But if you really don't care if this process01 throws an error or not, and you simply want to get as much value as you can from the other processes, then this wouldn't work for you. So now let's take a look at one approach that you can use to avoid having this sort of issue. So I'm going to close both of these files, and then I'll open this 03 solution directory, and here we have the exact same main.js file, but this time the process.js file is different. We again throw new error inside of the process01, and we again don't throw any errors in the process02 function, but we did add this try catch block into both of them. And what's going to happen is, as soon as this process01 throws an error, it is not going to actually bubble up to this part over here, but instead it will actually jump to this line in the same function and simply do this. And we'll see how this would totally save our lives if we want to get this value no matter what happens with the first process. So now let me actually start this example. I'm going to go back again and go back into this new example, and then I'll execute node main. And as you can see, process1 started and process1 failed, but we're still doing something after that. Then we are starting the process02, and then the process02 actually successfully ended after 3000 milliseconds. And then we see that we have undefined value from the process01, since that is the process that failed, but we do have a returned value from the process02 because that one was successfully executed. And we see that the total running time for this small example is 3000 milliseconds, because this first one failed, and then we didn't need to wait those 5000 milliseconds to pass by. So with these three examples, you should feel more and more confident in writing async. Obviously, the more you learn and the more you know about promises, it is going to benefit you a lot. So even if you're interested in async await exclusively, I would suggest that you take some time and go over promises in your spare time. But now let's take a look at what happens when we want to execute things using async await in parallel this time. Clear this console, I'll close this file, and then I'll navigate to our second directory that is called parallel. And again, as I already told you, we have three different subdirectories. So let's open the first one that is called naive, and let's take a look at it. So this time the idea is the same. Again, we have two processes and we want to run them, but this time we want to run them in parallel and not sequentially. That is what this small comment says. And how can we do that? Well, first of all, let me take a look at the process.js file just to show you that it is the same as we had previously, and it is also stripped of try-catch blocks, and we're throwing no errors this time. So in this main.js file, what we do first of all is we have this Promise.all function. Okay, so what this Promise.all function does is it returns a single promise to us that resolves when either all of the promises in its argument gets resolved, or if there are no promises over here. And this Promise.all also rejects with the reason of the first promise that got rejected in its argument. So all of that might be a bit confusing, but the most important thing is that Promise.all will call all of these for us and will return a single promise for us that will get, say, completed when all of these are completed. And if any of these fails, then the Promise.all will also fail on that returned promise with the reason of that failure. And what we can do here is that all the returned values from this get stored into this data variable that is actually an array, and then if we wanted to access the returned value from the process 01, since it is the first element in this array, we can access that by using the notation of 0. So we are referencing the 0th element of this array, and likewise for the second process returned value, it is second element in this array, and because it all starts from 0, that is the first element in that array. And if we actually run this example, and if I run it, we'll see that both processes this time started straight away. The process 02 is actually the first one that ended with 3000 milliseconds, then the process 01 ended with nearly 5000 milliseconds, and we can see that we have access to both of those returned values. And really importantly, this time we see that the total running time of this example is 5000 milliseconds, and it is not 8000 milliseconds like it was earlier, because like we have those two operations, and the operation 01 is the longest one, so the running time is pretty much going to equal the longest operation that we are running, because the other operations are going to be completed by that time. So this is all great and it is working. And now let's take a look at one potential issue that you might have with this approach. Okay, so I'll close all of this and let's go into the second folder. Okay, so the issue. Okay, so this is the same like it was before, but if we come to these processes, we see that it looks awfully similar to this example over here, and in fact I tried to keep them in the same manner. So the only change is this time we're throwing new error in the process 01, and let's see how that affects our Promise.all function. Now, if you remember what I just said, is that the Promise.all returns a single promise, and that single promise actually fails with the reason of the first promise that fails over here. So let's see what happens. I'm going to start this, and there it is. So we actually let me bring this up. So we started both of the processes, and then the process 01 failed, and then the process 02 ended, but as you can see, this never got executed because it jumped straight to this block over here. And the total time running, we also didn't see that because again all of this was avoided because of that error. So this is no good if you were interested in at least, say, this value over here, no matter that the first one failed. So the solution is going to be pretty similar to what we did in the solution for our sequential problem that was of the same nature pretty much. So let's quickly jump into it and see the difference. Okay, so the main is the same, and now let's jump into the process.js file and see what's changed. And it is similar to what we've been able to see before, so the only change is that we added the try-catch blocks into both of these functions, and again we're throwing new error inside of this process 01. So let's see how that affects things. So I'm going to navigate to that directory. and then I'll type node main, and as you can see, so both of them start running, but immediately the process 01 fails, and then we get a notification that process 02 started. But this could be slightly misleading because both of them got executed at the same time. So let me make one small adjustment, because now on the second look this could be a bit confusing. Let me just simply, before we throw new error, let me actually just await for, let's say, 100 milliseconds or so. Just want to show you that by reading this, you might think that this is executed sequential, because you see process 1 started, process 1 failed, and only then process 2 started. But if I actually rerun this example now, we see that both of the processes actually started, then the process 01 failed, and then the process 02 ended. And now we have access to all of these over here, because we handled the errors more carefully this time. And we see that process 01 returned, well, we don't know, it failed, but we have access to this value that process 02 returned, and it is correct one. And the total running time is 3000 milliseconds, because the first one failed and the second one was running for exactly that amount of time. So now if you ever need to run some operations in parallel that are not depending one of another, you can use the Promise.all. Just be careful with the errors. If any of such processes can actually throw an error, and most of the time they indeed can, make sure that you're handling those errors inside of them, and don't simply rely on those errors bubbling up in your main, because as you can see, it will totally mess up the application flow. So now we've seen sequential execution, we've seen parallel execution. Now we are going to take a look at loops and iterations and see how can you do that using async await. So I'll quickly close everything and I'll quickly close everything, and then I'll open the loops directory, and let's get started with a simple old good for loop. So I'm going to open the main, and this time the idea behind this example is different, which should be cool because we got a bit too used to the old example and that could be a bit boring by now. So this time we have our secret algorithm that we made, and we want to benchmark our algorithm and indeed make sure that it is running in the time that we think it is. So what we want to do is we want to run it multiple times and figure out the average running time. Okay, and here we have number of tests or number of runs that we want to do, and just thinking about that, let me actually rename this number of runs because that makes more sense. Okay, so we have number of runs that we want to do, we have our main function, and we have our for loop. So as long as I is less than number of runs, we want to do it and keep incrementing that I variable over here. So we pretty much just want to await secret algorithm 10 times in the loop. But we want to do but based on the description of this problem that we are dealing with, we are also interested in time. So I did pull in this performance-now module for the Node ecosystems, and I'm simply storing it in this new variable. And then what I simply do is I save the start time of each algorithm run, and after it is done, I then save the end time, and then I pretty much calculate the difference, meaning how long this secret algorithm was running for, and then we simply increment this variable that will hold all of the running times of our algorithms. And then what we do is at the end we say total time is exactly that, number of retries is number of runs that we have over here, and then we say the average running time is we simply divide this total time by the number of runs we actually did, and we simply format it to 3 decimal places, and in case of an error we simply error it over here. So it is really easy. The only confusing part could be this performance now, but that also should make sense. And now if I open this process file, things are slightly different this time. We again export some functions. This time we simply export one function, which is our secret algorithm after all. And then we again use time and time end to measure the running time. By the way, if you're wondering why we didn't simply use time and time end like we did in previous examples to measure this total time over here, well, it's because time and time.end actually just outputs the running time in our terminal, but we need to somehow store them in a variable and be able to divide them by the number of runs. So that's the reason why we needed to use this as well. So now let me get back to this. So what we do is we simply await some time, but this time isn't static. So instead, this is a small function that I wrote that will simply return a number between A and B. So here we're returning numbers between 1 and 7 inclusive. So both 1 and 7 could happen, and then we simply multiply that number with 100, and that's how we get our milliseconds that this secret algorithm should wait for. So it's really simple, and it is all like just made up for this example. But now let me run this and let's see what happens. So I'm going to navigate to 0, 3 loops and then 0, 1. Okay, and now if I execute that example, we see multiple secret algorithm runs over here. In fact, there are 10 of them. We then see that the total running time, so all of these values combined together, is 5000 and nearly 300 milliseconds. We then see that we had 10 retries, and once we divide this by 10, we see that our secret algorithm is running for roughly 500 milliseconds on average. So this is one example in which you can use simple old good for loop, and you can see how the regular for loop plays really nicely with await. We didn't do any new stuff really, we simply awaited whatever we wanted inside of our for loop and everything was well. So now let's take a look at the ForEach, which I really like, and I made a video about it in my ES6 series, and let's see what happens when we use it instead of this for loop. So I'll close both of those files and let me open the main.js. Now for this example, I wanted to create a slightly different example so that I keep things interesting and fresh. So in this example, we're actually running a grid of power plants, and we want to somehow group them together in a single array and be able to quickly turn all of them on and off. So we have this power plant class over here, and let us first of all take a look at that. So if I open this power plant file, we see that this is a simple ES6 class that is called power plant. We have a constructor, and in that constructor we simply pass in an ID. Now ID could be anything, so that's just like the name that we'll assign to that power plant in particular. And then we have two async functions to this class. We have turn on and turn off, and what we are doing, we are simply outputting that, like turning on power plant and then the name that we gave it, and then we're using time and time end to actually measure how long this turning on operation took. And then we're using again the same await, and we're getting some random number and we're multiplying that by 200 milliseconds. And then we simply do this for to get a new line, so that formatting is a bit prettier. Turn off function is exactly the same, we're just outputting different words to the console. Okay, so it's really easy to understand. And now inside of the main, what we're doing is we're creating a new array, new empty array of power plants. Then we are adding to that array a new power plant 5 times, and we are simply giving them an ID of 01, 02 through 05. And then what we want to do is really quickly to be able to turn all of them on and turn all of them off. So we use the ForEach helper for our power plants array, and then we get access to every power plant in that array, and for each power plant in that array we want to await an operation of turning it on and turning it off. So let's see what happens. So I'll navigate to that folder. and I'll type node main. And as you can see really quickly, something is really wrong and it's actually not even running. So it says syntax error, unexpected identifier, power plant, which is a bit weird because we kind of defined it over here, but the problem is simply that you can't use a wait keyword inside of your ForEach. So if you wanted to use ForEach with a wait, you unfortunately can't do it. But there are other ways that you can, and one solution to this problem is using the for-of. So we're going to take a look at that next. So let me close this file and let me open this next example, which is exactly the same, so I don't need to do any explaining. We again have the same situation, we again do the same things. We again have the same class over here. So the only difference is this time we're not using the ForEach, but we are using the for-of, which is you simply start with a for keyword and then you write like the name that you want to reference each and every element of some array, and then you simply type array name. So for every power plant that will be in the power plants array, we do something. And now like this needs to match our array, but this over here you can call it simply x if you want it. This is just a new variable for you that is scoped for just this block of code, and then you can use it over here. So I'm going to undo that because this makes more sense, but just so you're aware, this is the same that you had over here, so you could call this one x as well. Okay, so now in this for-of example, you can see everything is the same, and simply let's run it and see if this works this time. So I'll go back and I'll go in the for-of example and I'll start that off, and as you can see it seems to be working. So we are turning on power plants, so we turned on power plant 01, 02, 03, 04, 05, and all of that worked, and then we proceeded to turn all of them off with this piece of code over here, and we turned them all off. So this is example how you can use the for-of and how you can't use the ForEach. So that should be main takeaway from these two examples over here. And now for the final example, let's take a look at the while loop. So I'm going to close both of these files and I'll navigate here. So this time we're back again in our benchmarking example. So we are benchmarking our algorithm again. Let me simply rename it like I did in the previous. Okay, in the previous example, so we have really similar. So the secret algorithm is the same, so I don't need to do any explanation over here, but the main is a bit different. I mean, I made it so that we really want to use while, just so that I can demonstrate while loop. So what I did is we have this retries variable that is equal to 0, and we have total time which is equal to 0, and then we simply repeat this piece of code over here while the number of retries are less than the number of runs. So this over here will run 10 times, and then again we store the time before running algorithm, we store the time after running the algorithm, and then we save the difference in this variable over here. Now after each run of this algorithm we want to increment these retries, otherwise this will be in infinite while loop, and then at the end we simply output total time, number of retries, and the average running time. This time we can either divide it by number of runs constant, or we can divide it by retries, because they will store the same number in the end. So let me do that. Let me run this example. Okay, node main, and let's see what happens. Secret algorithm starts running 10 times, and this is our average running time. So this example simply wanted to demonstrate that you can use while, and that you can simply use a wait keyword in the while, and everything works as you would expect it to. So this is it. I have run out of examples unfortunately, so I don't have anything else to show you, but let's simply do a quick recap. So we've seen that during the evolution of async programming in JavaScript, we had different approaches with dealing the async code. We started with callbacks. We've seen that while they do get the job done, it isn't the prettiest code ever, and it can get really tedious to follow the logic of the code that you wrote. So that is the downside of callback approach. Then we have seen that the next best thing were promises, and in fact promises, we are also going to use promises in our async code. You've seen that Promise.all function. You've seen that if you have some legacy code, or simply the module that you're using is implementing the callback interface, meaning it is expecting you to pass in a callback function, you can't really use it directly in your async function. But what you can do is turn that function into a promise, and then you can use it with the await keyword. So promises are really important. They are what allowed the async to actually function. So be sure to study on promises. Then I briefly mentioned generators. Now I don't really have much experience using generators, so I didn't want to rush in and create some examples, because I don't think it's really necessary given that we have access to async await nowadays. And then finally we've seen about async await. We've not only seen a difference in code that it produces in the slide, but I've also walked you through all of these examples, and you will learn how you can do sequential things using async await like this. You've seen the potential issues, you've seen the potential solution in the try catch. Then we went over the parallel flow. You've seen how you can use Promise.all function over here. And then we again seen some issues and some solutions. And then last but not least, we've seen how you can use async await when you need to iterate over through some data. And we have discussed for loops, for each, for of, and while. So all of that should help you out in the future. And I hope you learned something from this video. It is a really long one, so congratulations for sticking with me through the end. Hopefully you learned something. It wasn't too complicated to follow me, and if you liked it, please leave me a like. If you dislike it, please dislike it, and if possible, let me know what I can do to improve in the future. Thanks for watching. See you in some of my other videos.